Hello guys, welcome to our information gallery. Today we are going to see the topic about embedded system. Now I am sharing the PDF is Introduction to Embedded System. The definition: an embedded system is an electronic or electromechanical system designed to perform specific function and is a combination of both hardware and firmware, means software. And it has a history also. Embedded system trace their history back to the 1960s. The Apollo guidance system, built by Charles Draper at MIT, is considered one of the first modern embedded systems used in the Apollo command module and lunar module. It was used for navigation, guidance, and control of the respective crafts using a numeric display and keypad. The Apollo guidance system was somewhat of risk since it was the first of its kind. Over the years, however, it was repeatedly used and for Minuteman I missile, built using discrete transistor logic and a hard disk for main memory, and ICBM, that is intercontinental basic ballistic missile, used by the United States Air Force. The highly specified systems were part of non-commercial projects and were thus extremely expensive. It wasn't until late 70s and Intel's 4004 microprocessor broke the path for cheaper and more market since it was significantly cheaper than general purpose computers. And it has classification of embedded system is based on generation, complexity, and performance requirements, based on deterministic behavior, based on triggering. Classification based on generation, like first generation, second generation, third generation, fourth generation. In first generation, these embedded systems were built using 8-bit microprocessor like 8085 and Z80 and 4-bit microcontrollers. They are simple in hardware circuits with firmware developed in assembly code. For examples, digital telephone keypads, stepper motor control units, etc. Second generation, these are embedded systems built using 16-bit microprocessors and 8 or 16-bit microcontrollers. The instruction set were much more complex and powerful than the first generation processors or controllers. Some of the second generation embedded systems contain embedded operating systems for their operation. For example, data acquisition systems, SCADA systems, etc. Next come to the third generation. These are embedded systems built using 32-bit processors and 16-bit microcontrollers. Application and domain specific processors controllers like digital signal processors DSP and application specific integrated circuit ASICs were introduced. The instruction set of processor become more complex and powerful, and the concept of instruction pipelining also evolved. Processors like Intel Pentium, Motorola 80K, etc. For example, robotics, media, industrial process control, networking, etc. Fourth generation. The invention of system on chips SoC, reconfigurable processor and multi-core processor are bringing high performance, tight integration, and miniaturization into the embedded device market. These systems make use of high-performance real-time embedded operating systems for their functioning. For example, smartphone devices, mobile internet devices, that's MIDs, etc. Next, second one, classification based on complexity and performance. This classification based on complexity and performance is as follows. First one, small scale embedded system. Small scale embedded systems are simple in application need, performance not time critical, built around low performance and low cost 8 or 16-bit microprocessor or controller, may or may not contain operating system for its functioning. Example, an electronic toy. B. Medium scale embedded system are slightly complex in hardware and firmware requirement, built around medium performance and low cost 16 or 32-bit microprocessor or microcontroller, usually contain operating system for its functioning. Example, industrial machine. In like industrial machine uses the fast uh, processor only. Next one, large scale embedded system, highly complex hardware and firmware built around 32 or 64-bit RISC microprocessor or microcontroller or PLDs or multi-core processor. Response is time critical and complex systems usually contains RTOS, real-time operating system, for task scheduling, prioritization and management. Example, mission critical applications. Classification based on deterministic behavior. This classification is applicable for real-time systems. The task execution behavior for an embedded system may be deterministic or non-deterministic. Based on the execution behavior real-time, embedded systems are divided into hard and soft. A hard real-time systems operate within the allotted time span. Soft real-time systems can miss some deadlines. And the fourth classification is classification based on triggering. Embedded systems which are reactive in nature can be based on triggering. Reactive system can be event triggering, time triggering. Come to the major applications areas of embedded system. First one, consumer electronics like camcorders, cameras, household appliances like washing machine, refrigerators, automotive industries like anti-lock braking system ABS, engine control, home automation and security systems like air conditioners, sprinklers, fire alarms, telecom like cellular phones, telephone switches, computer peripherals like printers, scanners, computer networking systems like network routers and switches, healthcare, EEG, ECG machines, banking and retail, automatic teller machine point of sales, card readers like barcode smart card readers. The purpose of embedded system with the example. Embedded systems are designed to serve the purpose of any one or combination of the following tasks. There are six following tasks is there. First one is data collection, storage, representation. Second one is data communication. Third one is data signal processing. Fourth one is monitoring. Fifth one is control. Sixth one application specific user interface. Come to the first one. Data collection, storage, representation. Embedded system designed for the purpose of data collection, perform acquisition of data from the external world. Data collection is usually done for storage, analysis, manipulation, and transmission. Data can be analog or digital. Embedded system with analog data capturing techniques collect data directly in the form of analog signal, whereas embedded system with digital data collect mechanism convert the analog signal to the digital signal using analog to digital converter. If the data is digital, it can be directly captured by digital embedded system. Like a digital camera is a typical example of embedded system with data collection or storage or representation of data. Images are captured and the captured images may be stored within the memory of the camera. The captured image can also be presented to the user through a graphic LCD unit. And second one, data communication. I'll tell the main points. I'll share the notes. I will give the notes, this PDF link in the description. In data communication, example for data communication is wireless modules, Bluetooth and Wi-Fi. Examples for wireline modules, USB and TCP/IP, network hubs, routers, switches are examples of dedicated data transmission embedded system. In data signal processing, a digital hearing aid is a typical example of an embedded system employing data processing. Digital hearing aid improves the hearing capacity of hearing impaired person. Fourth one is monitoring. All embedded products coming under the medical domain are with monitoring functions. Electrocardiogram (ECG) machine is intended to the monitoring of the heartbeat of a patient, but it cannot impose control over the heartbeat. Other examples with monitoring function are digital CRO cathode ray oscilloscope, DMM digital multimeters, and logic analyzers. Come to the next point is control. Air condition system used to control the room temperature to a specified limit is a typical example for control purpose. Then sixth one, application specific user interface. Button, switches, keypad, lights, bus, displays, unit, etc. are application specific user interfaces. Mobile phone is an example of application specific user interface. In mobile phone, the user interface is provided through the keypad, system speaker, vibration alert, etc. Next come to the general computing system versus embedded system. They given the criteria and general purpose computer and embedded system. In design, for general purpose computer designed to perform general tasks, designed to perform specific task in embedded system. Contents. In general purpose computer, it is a combination of generic hardware and general purpose operating system for executing a variety of applications. In embedded system, it is a combination of special purpose hardware and embedded OS, that is operating system, for executing specific set of application. Operating system. General purpose computer contains a general purpose operating system. Embedded system contains may or may not contain operating system. Alterations. In general purpose computer, applications are alterable by the user. In embedded system, applications are not alterable by the user. Key factor. In general purpose computer, performance key is the factor. In embedded system, application specific requirement are key factors. Power consumption. General purpose computer consumes more power. Embedded systems consumes less power. Response time. In general purpose computer, response time is not critical. In embedded system, response time is critical for some applications. Application. In general purpose computer, used for playing games, watching movies, creating software, work on document or spreadsheet, etc. Embedded system, used for particular application. Execution behavior. In general purpose computer need not be deterministic in execution behavior. In embedded system, execution behavior is deterministic for certain types of embedded system like hard real-time systems. Then come to the point, characteristics of embedded system. There are 6 characteristics of embedded system. First one is application and time domain specific. Second one is reactive and real time. Third one is operation in Earth environment. Fourth one is distributed. Fifth one is small side and wide. Sixth one is power concerns. In application and domain specific, an embedded system is designed for specific purpose only, and it will not do any other task. Example, a washing machine can only wash, it cannot cook. Certain embedded systems are specific to a domain. Example, a hearing aid is an application that belongs to the domain of signal processing. Then, reactive and real-time. Certain embedded systems are designed to react to the events that occur in nearby environment. Operation in harsh environment. Certain embedded systems are designed to operate in harsh environment like very high temperature of the deserts or very low temperature of the mountains or extreme rains. These embedded systems have to be capable of sustaining the environmental conditions they are designed to operate in. Fourth one is distributed. Certain embedded systems are part of a large system and thus forms components of a distributed system. These components are independent of each other but have to work together for the larger system to function properly. For example, a car has many embedded systems connected to its dashboard. Each one is independent embedded system, yet the entire car can be said to function properly only if all the systems work together. Fifth point is small size and weight. An embedded system that is compact in size and has light weight will be desirable or more popular than one that is bulky and heavy. Example, currently available cell phones. The cell phones that have the maximum features are popular but also their size and weight is an important characteristic. For convenience, users prefer mobile phones than the tablets, phone plus tablet PC. Then power concerns. It is desirable that the power utilization and heat dissipation of any embedded system be low. If more heat is dissipated, then additional units like heat sink or cooling fans need to be added to the circuit. If more power is required, then a battery of higher power or more batteries needed to be accommodated in the embedded system. What are the qualities attributes of embedded system? There are two quality attributes of embedded system: operational quality attributes, non-operational quality attributes. In operation quality attributes, it contains response, throughput, reliability, maintainability, security, safety. Come to the point. Response. Response is a measure of quickness of the system. It gives an idea about how fast the system is tracking the input variables. Most of the embedded system demand fast response which should be real time. Throughput. Throughput deals with the efficiency of system. It can be defined as rate of production or process of a defined process over a started period of time. Reliability. Reliability is a measure of how much percentage you rely upon proper functioning of the system. Mean time between failures (MTBF) and mean time to repair (MTT) are terms used in defining system reliability. Next, maintainability. Maintainability deals with support and maintenance to the end user. It can be classified into two types: scheduled or periodic maintenance. For example, periodic cleaning of air conditioners and refilling of printer cartridge. Second one, maintenance due to unexpected failure. For example, air conditioner not powering on and printer not taking paper in spite of full paper stack. Next point is security. Stones of information security, confidentiality, integrity, and availability are three corners. For example, an electronic safety deposit locker can be used only with a PIN number like a password. Next point is safety. Safety deals with the possible damage that can happen to the operating person and environment due to the breakdown of an embedded system or due to the emission of hazardous material from the embedded products. Next quality attributes of embedded system is non-operational quality attributes, that is testability and debuggability, evolvability, portability, time to prototype and market, and per unit and total cost. In testability and debuggability, it deals with how easily one can test his or her design application and by which mean he or she can test it. Evolvability for embedded system, the qualitative attribute evolvability refers to the easy with which the embedded product can be modified to take advantage of new firmware or hardware technology. Portability. Portability measures system independence. Time to prototype and market. Time to market is the time elapsed between the conceptualization of a product and time at which the product is ready for selling. Per unit and total cost. Cost is an important factor which needs to be carefully monitored. Monitor. Application case study smart running shoes. It is a lot of theory. I will give notes link in the description. Please subscribe. Sorry for I'm not creating PPT for this unit 1. For next chapter I will create PPT separate and give the notes link separate. Please subscribe and watch. Thank you for watching.